Students, this is a Digital Knowledge Irshad Academy with a new video of laws of Boolean Algebra. Today we are going to discuss fourth law, which is called Annulment law. It has again two parts, addition and multiplication. Before going to circuit explanations, let us refresh our knowledge on OR logic gate. This has already been told you that this is lecture 22. See that two switches in parallel, two diodes in parallel, and these are the two transistors in parallel. Transistor T2, the B input is held at logic 1 voltage. This is forward biased and conducting current from ground through RL through base to VCC back to ground and then reaches, and there is a voltage drop which we get here, and it is a logic 1 voltage. And A is held at 0, mean low level logic voltage. T1 is cut off, does not matter. Why? Because T2 is always conducting and providing us logic 1 voltage. With 0 logic voltage here, the T1 is cut off. Then when A is held at logic 1, we are applying logic 1 voltage. T1 is also forward bias, and now T1 starts conducting. Both transistors conducting, since they are in parallel, the current divides in parallel. The path for T2 conduction is from RL through emitter through base to VCC to ground and back to RL. We are getting logic 1 voltage here, irrespective whether A is 0 or 1. Since B is held at 1, is providing us logic 1 voltage. That this has to be remembered. And second is the for law of multiplication. We are going to refresh our knowledge on AND logic gate. This time these two transistors are in series, T1 and T2, they are in series. B input is held at 0, mean this is not forward biased, therefore no current is passing and we do not get any output. The output is 0. Now let us give logic 0 voltage here. This remains cut off, no current passing through both transistors, no output, or we say 0 output. When logic 1 voltage is applied at A, T1 is forward biased, but since T2 is cut off, there is no current passing. In both cases, whether A is 0 or 1, we get 0 in the output. That is the definition of annulment law of multiplication. Let us now go to circuit explanation. Now this is the B switch. It is closed permanently. This is switch A. Now this is held at 1. This one is representing B switch. Now, although A is open, the current can flow and find a path through B and the lamp lights. We get logic 1 in the output when A is open and B is permanently closed. And when A is 1, that means A is closed, the current flows through this branch, current flows through this branch, and the lamp lights. In both cases, whether A is open or closed, the lamp lights we get logic 1 voltage. Let us draw the truth table. This is B switch, which is fixed value, and it is held at logic 1. Why? Because it is closed. This is A, and this is the output X. X is the output here we get x. Now let us see that A is 0, we are applying logic 0 voltage. Is a OR gate, 0 plus 1, in the output we get 1 here. And when A is 1, 1 and 1 odd 1, OR gate, 1 odd 1 is 1. See that when A is 0, the output is 1. When A is 1, output is 1. This is law of addition, states that if a variable can be A, it can be X or any alphabet, the output is always 1. This is called annulment law of addition. It states that when a variable is odd with 1, it always equals, output always equals 1, and we have proved with the help of switches. This is a B switch. It is fixed, it is held at 1. Closed switch is representing 1. It is 1 here. A is the second input to the OR gate. Say if it is 0, the OR gate ends 1 plus 0 is 1. And when A is 1, 1 plus 1 is 1. In both cases, when A is 0, output is 1. When A is 1, output is 1. And we have proved that A odd 1 equals 1, and it is 1 and 1, referring to two transistors in parallel. One is always conducting, the other is open. No matter, the current is still flowing through the emitter. Now going to the second part, multiplication. These are the two switches. This is switch B and this is open. Open switch represents 0, 0, this is 0, and this is A. Say for example, if we are applying a logic 0 voltage, that is a low logic voltage, 0 into 0, the output is 0. When A is 1, 1 multiplied by 0 is an AND gate. 1 ANDed 0, 0 ANDed 1 is 0. In both cases, the output is 0. Or we can say, when a variable is ANDed with 0, the output is always 0. This is law of multiplication. Annulment law of multiplication states if a variable is ANDed with 0, the output is 0. And here it is switch A. Alright, if switch A is open, there is no current flowing. And when you close this switch, although switch A is closed, is 1, but it is open here. In both cases, the lamp is not glowing, lamp is off, and we get logic 0 voltage. And the law states, is defined as, if a variable is ANDed with 0, output is always 0. Switch open switch represents 0. This is 0, 0. A switch, if it is closed, is logic 1. This is logic 1. But the path is broken. Why? Because both switches are in series, as we have seen with the help of two transistors in series. Now going to the summary points. Laws of Boolean algebra, annulment law, the law of addition. The definition is variable odd with 1 always equals 1. A plus 1 is equal to 1. This is 1. B is permanently closed and is 1, permanently 1. And then switch A is closed or open. The B position is in both cases 1, 1. Now let us see that we are applying a low level voltage, that is logic 0. 0 plus 1 in the output we get 1. When switch A is closed, this is 1. Both are 1, 1. B is already closed, and now I have closed A switch. The output is 1. Why? Because current is flowing through both the branches and lamp is lighting. This is called an annulment law of addition. Is a R function. Definition: variable, any variable odd with 1 equals 1. This is a 1 variable and it is odd with A. 0 plus 1 is 1. 1 plus 1 is 1. 1 plus 1 is 1. Going over to the second part, multiplication. It is defined variable ended with 0 always equals 0. That is A ended 0 is 0. This is open switch. This is open. B is open. B is 0. B is 0 here. A can be 0 or 1. Let us see. We are applying logic 0. 0 multiplied by 0 is 0. And when logic 1 voltage is applied, 1 multiplied by 0 is 0. Multiplied by 1 is 0. In both cases, whether you close this A switch or open this switch, the lamp is not lighting and we get 0 logic voltage. This is 0 and 0. Finally, going to the conclusion, addition, variable odd with 1 always equals 1. This you have to remember. A odd 1 equals 1. Multiplication, A ended 0 equals 0. This is a law, annulment law of addition. This is annulment law of multiplication. This you have to remember. In the next video, we'll discuss identity law. That's all. Thank you very much.